First, you have to be aware that there's the resting membrane potential. Then it has a stimuli transmitted from the neurotransmitters. There's action potential frequency that's propagated along the axon to the neuromuscular junction. Then the voltage regulated calcium channels are opened for the diffusion down the gradient of calcium. The rapid influx of the calcium signals to the synaptic vesicles containing the acetylcholine, which will then go through exocytosis, diffusing across the synaptic cleft, binding to the receptor sites on the motor end plate. The chemically regulated sodium-potassium channels will then open, diffusions or leaking in and out of the sodium. Rapid flood into the sarcoplasm will cause the depolarization. Once the threshold is reached, the action potential will then propagate over the sarcolemma, traveling down the T-tubules, activating the whole triad, which therefore the voltage-regulated calcium channels in the sarcomere will open, and the calcium will then diffuse into the sarcoplasm. Then the calcium will bind to the troponin that then changes conformation. Due to its bond with the tropomyosin will expose the active sites on the G-actin. Once the active sites are exposed, the cocked myosin heads will bind to the active sites to create a cross bridge. Once the cross bridge is formed, it immediately goes through a power stroke. Once that action is carried out, it detaches. Causes the muscle to shorten, which is only 1% of the contraction. It will continue to fire as long as the ATPase comes and breaks the phosphate from the ATP through hydrolysis. The energy release from that bond breaking will recock the head, and the power stroke will happen again. Once the stimuli is no longer propagated and the potassium sodium pump repolarizes the resting membrane potential, the calcium in the sarcoplasm will go through reuptake and active transport, go back into the cisternum, and then it goes back to the normal resting place, and the myosin heads will remain cocked.